All right, so I've got three examples here of problems with fractions, and you might notice that they get sort of progressively hairier, but don't worry, these are all problems you're completely capable of doing. In fact, you might want to pause the recording right now and give them a try. See how far you get on each of these three guys, and then come back and join me for the solutions. Okay, so check that out. And now I'm going to get started on that first one. I'll just recopy it here. So the first one was 1 over x minus 2 minus 1 over x plus 2. Okay, so no common denominator here. And I'm not even going to worry about what's the lowest common denominator. I'm just going to notice that the product of the denominators will work. So I'm going to multiply 1 over x minus 2, that first term, times x plus 2 over x plus 2, and I'm gonna subtract from that. Very important to keep track of what's a minus sign and what's a plus sign here. Subtract, because I've got a minus sign here, minus sign there, 1 over x plus 2 times 1 over x minus 2 over x minus 2. Okay, so what I've done is my standard thing is I've multiplied the first term by 1 in the form of x plus 2 over x plus 2, and the second term by 1 in the form of x minus 2 over x minus 2. Both of those equal 1, so it's perfectly valid, but that's going to give me everything over the common denominator of x plus 2, x minus 2, and so that's my common denominator there. And now for my first term, I've got the x plus 2 there. So x plus 2 minus x minus 2. With these negative signs, it's really important to remember that this negative sign is hitting the whole numerator here. So that's why I've got my parentheses. So I've got my common denominator taken care of here. That equals x plus 2 minus x plus 2. Okay, so minus x minus negative 2 gives me a plus 2 there. Over, let's do the denominator 2. Oh, look what we have here. We have the product of sum and difference. We know that that is the difference of perfect squares. That's x squared minus 4. Multiply it out if you don't remember or don't believe me, but that really is what it is. And now I can see that this x and that x cancel. X minus x, x's go away. And I'm left with 4 over x squared minus 4. Okay, so that wasn't so bad. Now let's look at this next guy. And let's carefully recopy that. 1 over 8 AB minus 1 over 8B A plus 2 plus 1 over B A squared minus 4. Okay, that's quite a thing. What do we have here for a common denominator? Well, we've got the 8AB, a plus 2, and a squared minus 4. I could just multiply it all out, but I might also just notice that same deal as before, a squared minus 4 equals the product of a plus 2 and a minus 2. So I might use that. So what this lets me know is that the common denominator is 8ab a squared minus 4. Okay, and the reason why that is because there is an a plus 2 lurking in here. All right, so let's put everything over that common denominator. We've got 1 over 8ab. So what do I need? In the bottom, what I need that I don't have there is the a squared minus 4. So I've got a squared minus 4 in the bottom. I better have it in the top too. Minus, the next term is 8b over a plus 2. And what do I need there? I've got the 8b, but what I don't have is an a, and I have the a plus 2 here from a squared minus 4, but I don't have the a minus 2. So what I need to add there is minus 2. And so if that's in the bottom, that better be in the top as well. And then the last term, 1 plus b squared minus 4. What do I need here? Well, I'm missing the 8a in both places. All right, let's just stop and pause here. So all I've done is I've taken my 3 terms in the sum, and I've multiplied each of them by 1 in the form that I need to get them over the common denominator. So what I needed for this first term was to get the a squared minus 4 there. So if I need it in the bottom, I better multiply by the top 2. In the next term, I had 8b, and part of the a squared minus 4, I had this a plus 2 factor, but I was missing the a minus 2, and I was missing the a. So I've got my a times a minus 2 here. In the final term, I had the b and the a squared minus 4, but I was missing the 8a. So there's that's all I need to get it over a common denominator. Now I just need to put everything together here. All right. So I'm going to have one nice big thing here, and my fraction in the bottom will be the common denominator. My number in the bottom will be the common denominator, 8ab a squared minus 4, because that's what I've got every place now. I've got 8ab a squared minus 4, 8ab, and these two things together give me a squared minus 4. I've got 8ab a squared minus 4. So it's really good. Done what I need to every place. And now let's just organize the numerator here. We've got to get those guys in here. So first term, a squared minus 4. Second term, remember that negative is hitting the whole second term, so it's minus a times a minus 2. Let's multiply that out. It's a squared minus 2a. Okay, see what I did here? I've got the minus sign there, hitting all of this. And for my a times the quantity a minus 2, I've got a squared minus 2a. Last term is just plus 8a. Okay. So good so far. Let's keep working on that numerator. Squared minus 4 minus a squared plus 2a plus 8a. Just wanted to distribute this negative sign. This is a place where I'm really super likely to make mistakes, is with negative signs hitting parentheses. So I'm going to just do that in a step by itself. Copy that old denominator there. It's the same as it was before. Now let's combine terms here. Oh, look at this. The positive a squared, the negative a squared cancel out. So we're left with negative 4 plus 2a plus 8a. That sounds like 10a plus 10a over 8ab a squared minus 4. Okay, so kind of looking back over what we've done here, the problem got like kind of big and hairy, but now we're able to simplify it again. And that's like something you see over and over again. The first step of simplifying, things are getting much less simple, but then you're able to organize things and pare them down into something that will in fact be simpler than what you started with. In fact, we could even simplify a little bit more. Here, we can do one more step. We can notice that there's a factor of 2 in both the numerator and the denominator. Okay? That is 2 times negative 2 plus 5a over 2 times 4ab squared minus 4. So those 2's cancel out. It's another factor of 1 that we can divide out. I kind of like to start things with positive numbers when I can, so I'm just going to rewrite the 5a minus 2. That is maybe one of my little quirks. Doesn't really matter. A minus 2, 4ab h squared minus 4. And that is our answer. All right, wasn't so bad, really, right? That looks so messy and writing big. I fit it on one page here. We've got one more problem to do. So this is our fractions of fractions problem. Got 1 over x squared minus 1 over y squared. That whole thing divided by 1 over x squared plus 1 over y squared. Okay, so we know we're going to eventually take what's in the denominator and multiply the numerator by its reciprocal. But right now, it's not even a single fraction in the denominator. So one thing that we have to do is put both the numerator and the denominator themselves over a common denominator. So we're going to do that common denominator thing in the numerator and in the denominator. Fine. And again, we're just going to not worry about keeping the lowest common denominator. We're just going to say that the product of the component denominators will be a perfectly good common denominator. So that is equal to 1 over x squared times y squared over y squared minus 1 over y squared times x squared over x squared divided by 1 over x squared. Same deal as before, y squared over y squared, but now it's plus 1 over y squared, x squared over x squared. That equals, in the numerator, y squared minus x squared over x squared, y squared, divided by y squared plus x squared over x squared, y squared. Oh, look, I can cancel out the 1 over x squared, y squared from both the numerator and the denominator. And that equals y squared minus x squared divided by y squared plus x squared. Okay, and that is indeed my answer. Yes, you might be thinking we could factor y squared minus x squared into y plus x and y times y minus x, but we can't factor the denominator, so there's really nothing gained. All right, so these examples showed using the rules of fractions, common denominator, nested fractions, common factors, all of those things in the context of problems where we're using a lot of techniques from our previous lessons. You're going to see that going forward. Everything that we're learning in these early lessons is going to help us do the problems in the later lessons. So go ahead and try out some problems with fractions, and I'll see you in the next lesson.